Today we are going to continue with JEE Trigonometry and we'll be doing the second session. Sometimes, so we have already discussed 3 topics and now we move on to topic 4. Sometimes the expression which is given, a trigonometric expression, so we may be told to find the maximum and minimum value of this. So for example, let's say you are told to find the maximum and minimum value of sec square theta minus tan theta divided by sec square theta plus tan theta. So you can write it in this fashion. So if you substitute tan theta is equal to P, then y is p square minus p plus 1 by p square plus p plus 1. So p square into y minus 1 plus p into y plus 1 plus y minus 1 is 0. So since p is real, the discriminant of the quadratic will be positive. So this will be the relation. So 3y minus 1 into 3 minus y is greater than or equal to 0. So 3y minus 1 into y minus 3 is less than or equal to 0. So that means the maximum value is 3 and the minimum value is 1 by 3. So this is an example how to find the maximum or minimum value of a trigonometric expression. Now in order to find the maximum and minimum value in this particular sum, we used quadratic equations concept. What are the other kind of questions other than this? So root over a square cos square theta plus b square sin square theta plus root over a square sin square theta plus b square cos square theta. Suppose we have to find the range of this. So how do we proceed in this kind of a question? So we are basically getting an expression like this. So this entire expression, suppose if you square it, then after squaring it, this is what you will get. So I am repeating again, there was one expression, we have to find the maximum and minimum value. So I am suggesting that we square this expression, which means we square this. So that will lead us to this. Now here the maximum value of cos square 2 theta is plus 1. If you put cos square 2 theta as plus 1 and the minimum value of cos square 2 theta is 0, so if you put cos square 2 theta as 0, then this is what you will get. This is if cos square 2 theta is 0, then this is what we will get. On the other hand, if cos square 2 theta is 1, then this is what we will get. Now remember, in order to get these two answers, we had squared the original expression. So now we can say that the original expression has a maximum value of a plus b and a minimum value of a plus b and a maximum value of root 2 into a square plus b square. So this is another kind of sum which we can get from this topic, that is topic 4. Now we come to topic 5. Suppose you have a series like this, sine a plus d, and like this the last term is sine a plus n minus 1 into d. So let us call this series as S. You multiply both sides with 2 sine half d. So if you multiply both sides with 2 sine half d, this is what you will get. So cos a minus half d minus cos a plus half d. Then cos a plus half d minus a plus 3d by 2, and this will continue till we reach the last term. And when we reach the last term, this is what we will get. So finally, except this term and this term, all the others will get cancelled out. So we are going to get cos a minus half d minus cos a plus nd minus half d. So this is giving 2 sine a nd a plus nd minus d by 2 into sine nd by 2. So this gives us the formula S is equal to sine half a plus half d into n minus 1 into sine nd by 2 by sine d by 2. Similarly, if you have a cosine series, suppose I call it as S dash, suppose you have a cosine series and the name is S dash. So S dash will be sine So S dash will be cos half a plus half d into n minus 1 into sine n into half d. So these are the two series, and these two have to be remembered. They have to be committed to memory for the joint entrance examinations. These two can be used as ready-made formulas. What kind of questions can we get from this topic? Now let us say there is a series cos pi by 11 plus cos 3 pi by 11 plus cos 5 pi by 11 plus cos 7 pi by 11 plus cos 9 pi by 11. Suppose there is a series like this. So let it equal to S. So you multiply both sides with 2 sine pi by 11. So 2 sin pi by 11 cos pi by 11 plus 2 sin pi by 11 cos 3 pi by 11. And in the end we are getting 2 sin pi by 11 cos 9 pi by 11. So we will be getting a series which after expansion will ultimately give only one term, sine 10 pi by 11, and all other terms will cancel. So S will be equal to half. So this is one example of how to solve the trigonometric series like sine series or cosine series. Now we come to topic number 6. Now this is a very interesting topic. It's called series of pi by 7 and its multiples. So suppose we begin like this. Let's say theta is equal to pi by 7 or 3 pi by 7 or 5 pi by 7. Suppose theta has these values. So we can say that 7 theta is pi or 3 pi or 4 pi. So that means 4 theta is pi minus 3 theta or 3 pi minus 3 theta or 5 pi minus 3 theta. So if you take sine on both sides, you will get sine 4 theta is equal to sine 3 theta. So we can write 2 sine 2 theta cos 2 theta is 3 sine theta minus 4 sine cube theta. So 4 cos theta cos 2 theta is 3 minus 4 sine square theta. So 8 cos cube theta minus 4 cos square theta minus 4 cos theta plus 1 is 0. So this is an equation whose roots are cos pi by 7, cos 3 pi by 7 and cos 5 pi by 7. So what are the conclusions we can derive? So we can say that cos pi by 7 plus cos 3 pi by 7 plus cos 5 pi by 7 is equal to half. That is the first conclusion. Second conclusion is cos pi by 7 cos 3 pi by 7 cos 5 pi by 7 is equal to minus 1 by 8, and we can also say that cos pi by 7 into cos 3 pi by 7 plus cos 3 pi by 7 into cos 5 pi by 7 plus cos 5 pi by 7 into cos pi by 7 is minus half. So we are getting basically three equations. Now, using this, we can also have some other types of equations. For example, suppose we are asked to find the value of sin pi by 7 into sin 2 pi by 7 into sin 3 pi by 7. Suppose we have to find the value of this. So if you square it, then we'll get this. Actually, sin square 2 pi by 7 can also be written as 1 minus cos square 5 pi by 7. So we will get 1 minus this plus cos square pi by 7 cos square 5 pi by 7 plus cos square pi by 7 into cos square 3 pi by 7 plus cos square 5 pi by 7 plus cos square 3 pi by 7 minus cos square pi by 7 into cos square 3 pi by 7 into cos square 5 pi by 7. So using algebraic identities, cos square pi by 7 plus cos square 3 pi by 7 plus cos square 5 pi by 7, it can be written as half whole square minus 2 into minus half, and this term which is inside the bracket, this can be written as minus half whole square minus 2 into minus 1 by 8 into half, and the term which is at the extreme can be written as minus 1 by 8 whole square. So if you simplify this, it will come to 7 by 64. So now we can say that sine pi by 7, sine 2 pi by 7, sine 3 pi by 7 is root 7 by 8. So this is how we can do the questions of topic 6, and that brings us to an end of this session of trigonometry 2.